everyone, welcome to the session. So in this particular session, I'll talk about other few problems which are based on logarithmic time complexity, right? Until so far, we have seen that how we can evaluate the time complexity, and we have seen O of n of n square, right? Using for loop and while loop. Today we will try to see other types of time complexities as well, specifically in terms of logarithmic, how we can compute and how it will look like. So let me take the example here. Let's get started. So suppose here I am having the main function, okay? And inside this main function, again, what I'm trying to do is that I'm saying that the value of I is something which is equals to n. And then I'm saying, again, I am applying one while loop, and I am saying while the value of I is greater than 2, do one thing for me, just I to the power 1 by 2. Now, can you tell me that what is the overall time complexity required to run or to execute this code in terms of big O, in terms of worst case time analysis that we are talking about? Okay, I think this is the example number 6 which I am demonstrating in my videos, right? Until now we have covered up 5 examples in our previous sessions, 3 in the very first and 2 in the very next particular video. So I hope that with every example you are getting something different, you are getting something knowledgeable, and that's why I am trying to cover up all the different types of time complexity analysis part. Okay. Now here if you will try to see, again I'll say that try to start from some random number. For example, I am saying that the value of n is something equals to 256. Okay. Now what I am saying is that 256 is somehow greater than 2. Yes. So the value of I will become now 256 to the power 1 by 2. Now this can be written as 2 to the power 8, right? To the power 1 by 2, and this can be written as 2 to the power 4, which is somewhere equals to 16. So here if you will see, because the condition will get satisfied, it is true. So in this particular case, what we are getting is 16. Now again, second part is 16 is greater than 2. This is true. So now what is happening is that the value of I is equals to 16 to the power 1 by 2. Again, this can be written as 2 to the power 4 to the power 1 by 2. So this is something which is equals to 2 to the power 2, which is equals to 4. So here also if you will see, condition is getting satisfied, and that's why we are going inside the while loop and the statement will get executed. Coming towards the next part, again here if you will see, next important thing is 4 is again greater than 2. So again the condition will become true. Now the value of I will become 4 to the power 1 by 2. So it is something which is equals to 2, right? Now in the next important case, what will happen is that is the value of 2 is greater than 2. Here is something which is happening interestingly. This condition is somehow we are getting as false. Means this is not applicable. Now here if you will see how many times this code is running, or I would say how many times internally the inside while loop statement will run. This is the first time, right? Because the condition will get true. Then this is the second time because the condition will get true. This is the third time because the condition will get true. So 3 times the condition is getting true here. So it means that when the value of n is 256, my execution is happening, or the statement is running inside the loop 3 number of times. Now the question is that basically how many number of times, the question is how many number of times we are doing to the power 1 by 2, right? Suppose I am doing k number of times. Until what time I will stop? I will stop when the value is equals to 2, right? Because after that only, when I reach to the next equation, it will become false. I hope I am making sense, right? So here you have to see that until how much time you will keep on doing this task. Here if you will see, initially what you are doing n to the power 1 by 2. Then in a way you are doing n to the power 1 by 2 to the power 2. And to the power 1 by 2 to the power 3, and so on. So majorly what is happening is that initially you have the number n, right? Because your value of I you have initialized with the value of n. Then what you are doing? You are doing n to the power 1 by 2, right? In the second step, what you are doing whatsoever number you are having. If the condition is true, again you are doing. So can I write it as n by 1 to the power 2, right? Similarly, if suppose this number is also satisfying the while condition, we are saying 1 by 2, above number as it is, again 1 by 2. So that's what I am saying. Here we are doing n by 1 to the power 2 by 3. So until what point of time we will do? Suppose I am doing k times. And then I am getting 1 by 2 to the power k. Now, these many times, it means the condition of while loop is satisfying. It means these many times my code is executing that particular statement. Now our objective is to find out this particular value of k. This is the important thing that we have to find out. How we can find out the value of k? So here if you will see, we are saying n by 1 to the power k, which is somehow equal to 2. Which is somehow equals to 2, because this is the point where I know that the condition will become false. When this value is equals to 2, at the next instant itself, it will not satisfy the criteria. Now what we can do is that we can just take log on both sides. We can just take log on both sides. So now what will happen? This 1 by 2 to the power k will come up front. Log of n base 2. We will take log base 2 on both sides. So I hope everyone knows that log of n, suppose base a power is b. So we can write it as b can come up front. So we can write it as b log of n base a, right? Like this as well. So when I'm taking log of base 2 n to the power 1 by 2 to the power k, so what I'm saying is that I am taking the power term up front. So that's how this equation we are getting, right? Now we know that when this is again the logarithmic property, log of a base a is equals to 1. So when we are having the base as well as the value as same, they cancel out each other and the value is equals to 1. Now what you can do is that the value of log of n base 2 is somehow, this is 1. So this is equals to 2 to the power k. Now you can easily calculate what is the value of k. What you can do is that again you can take the value of log base 2 again. So log of base 2, already you have log base 2n, completely we are taking the log. Again power term we can take up front. So it will be k log of 2 base 2. Again this value will become equals to 1. So k into 1 is nothing but is equals to k. It means that we are trying to get the value of k, means how many number of times internal statement will get executed. What is the internal statement? This statement I am talking about. It means that this statement is executing log base 2 n number of times. Means this is the overall time complexity, which is big O of log of n. There is also no need to specifically type that which particular base you are having. If you want, you can, obviously. Right? This is the way to calculate the time complexity in terms of a logarithmic thing. It is very much important that you should have a basic understanding of how basically logarithmic work and what are the important properties of logs that we have, right? Apart from that, it's pretty easy. I hope everyone is able to get sense out of this. Again, let's take one more example, and after that, I think we can wrap up this video as well. So this is the last example which I am talking about in terms of finding out the time complexity. So this is the example number 7, I believe, right? So here if you will see, what we can take is that I will take the same code. Again, for this particular example, please try to, after seeing the question, pause the video, try to do it on your own. If you are able to solve it correctly, it means you will be able to get the understanding. And suppose you are not getting that, then try to unpause the video, try to see where you are doing wrong. Then only you will be able to understand what I want to convey here. Okay. So here again, I am having the main method. Inside this main, what I am saying is that the value of I is equals to n. After that, I am saying that the while loop is there. Inside this, I am saying the value of I is greater than 2. And when this is happening, the value of I is equals to I to the power 1 by 25. Suppose this is the problem logic that I have written. Now I am telling to you that can you tell me what is the overall time complexity required? Now here if you will try to observe, we are starting from n, right? Then we are doing n when this condition of while loop will become true, we are doing n to the power 1 by 25. Again, we are doing 1 by 25 and then 1 by 25, right? Again, when again this condition is true, this condition is true, when it will move ahead, it will be 1 by 25, 1 by 25 complete number and then 1 by 25. So basically what we are trying to do is that we are trying to take 1 by 25 at each and every instant whenever the condition is getting true. It means that we need to run until k number of times. When it will get stopped, when this condition will get satisfied, means that value is equals to 2, right? Until that point of time, I will keep on doing 1 by 25 because until that point of time, it will execute this statement. I hope I'm making sense to everyone. Exactly the same example, just the numbers are different that I'm writing here. Now, what we can do is that we can again take log on both sides. Just take log base 2, okay, on both of the sides. Very simple. Now, just take log base 2 n by 1 by 25 to the power k, which is equals to log of 2 base 2. Here if you will see, again I am getting the value as 1. Now what we can do is that this number will move up front, 1 by 25 to the power k, as I talk about the property, which is equals to 1. So here if you will see, log of n base 2, which is equals to 25 to the power k, right? Just take again log base 25 on both sides. Log of n base 2, which is equals to k log 25 base 25. This value will become 1. It means that what we are getting the value of k as log 25. Inside that we are getting log of n base 2. And this is the overall time complexity that we are getting. So the time complexity to solve this problem, or how many times that particular while loop condition inside that it will execute, it will be order of log 25 and inside that log of n base 2, right? This is the overall time complexity of this particular code. Here if you will observe one pattern. So what we are getting here, log base 25, log base 25, log base 2 n. This is what we are getting, right? This is what we are getting. So here one pattern you will observe. What is happening is that whenever you are seeing this kind of problem, so whatsoever is there inside your while loop, that base is coming outside in terms of logarithmic, and whatsoever is the condition that you have, that particular logarithmic will come inside the bracket. That's the another way of inference of this logarithmic. That's what I'm talking about here. So without solving this also, if you will be able to get sense of this code, the way it is written, you will be able to get an idea and you can directly say that this is the overall big O time complexity that we are getting. For example, instead of this number, I am saying 1 by suppose 30. So what will happen is that instead of this 25, you will get log base 30, log base 2 n, and overall it will be a big O, and this is how you will be able to get the overall time complexity. It's just a game of numbers, right? So the approach with the help of which I am trying to convey that how basically this time complexity is computed with the help of these several examples. Here I think I have created 3 separate videos where I have started from scratch, which is a constant based time complexity, and move ahead towards the complex one, right? In order to just demonstrate you that what's the idea and what's the logic behind evaluating the time complexity part, the a priori analysis that we are trying to do, the approximations that we are trying to find out, right, is pretty much clear to everyone. So if you still have any sort of doubt, do let me know. Obviously, I'll try to resolve it as soon as possible. And with this, let me close this session. Happy learning to all. Bye-bye everyone. See you soon in the next upcoming session.